So that's what I'm going to be talking about today. So my name is Joris Kuipers. I work for Trifork. As Kalina said, I'm CTO there. That doesn't mean that I'm just doing management 5 days a week. It actually means that I'm still doing a lot of hands-on work as an architect on projects and working with technology like Spring on a day-to-day basis. Trifork is also the company that hosts the GOTO Academy. So we do Spring trainings. That's not something that we actually create ourselves. These are the official trainings from VMware, but we deliver them here in the Netherlands. So for today's topic, I chose observability. And observability is a term that's been around for a while now. It became popular, I would say, around 2017, that I started to hear it a lot and see it on Twitter and blogs and that sort of thing. It's been around for a bit longer already. And in the beginning, a lot of people were wondering, well, why do we even need the term observability? What is this thing? Isn't this just monitoring for hipsters? Something like that. So you can see a tweet to that effect here from Cindy. Very interesting to follow, by the way, if you are into distributed systems and theory behind that. But actually, when it comes to monitoring versus observability, there are some significant differences. And one of them is that with observability, the idea is that when you have a system running in production, you want to be able to see what it does internally at all times, not just for seeing known failure modes, right? Knowing that something can be up or down, or that your disk can be full or still has some space, but actually to simply see all sorts of different things that you may not even have thought of up front, that they might be important for doing things like troubleshooting, so that you get a complete picture of what your system is doing. And it should be possible to do that without the need to deploy new software, right? If you're only going to say, well, I see that something is wrong now, let me put in some additional logging and then I'll redeploy and then I will be able to understand what's happening. That's not the goal. The goal with observability is to be able to say, well, on the spot, at runtime, I need to be able to understand what my system is doing. And obviously, that overlaps with monitoring, right? You still want to be able to see the known knowns. I know that I'm interested in certain values because it will indicate an error if they deviate from what I expect. But it also enables you to monitor your unknowns, right? Maybe I don't know up front what exactly the stuff is that I won't be able to look at in order to troubleshoot something. I just need to be able to explore it. And that explorative mode of finding out what your system is doing, either right now or maybe over time, that's one of the key characteristics that defines observability. Now, when it comes to what this actually means in practice, a lot of people talk about the 3 pillars of observability, which you can see here. It's good old logging. Right, just logging from an application to have individual events that indicate what is happening at a particular time. There is metrics. That is more of an aggregated way of observing your system, and I'll talk more about these at length in the presentation. And finally, there's tracing, where you can actually see how a single request that comes in to your system boundary actually flows through the whole platform, which is especially interesting if you have a microservices-based architecture where multiple services are involved in handling a single request that comes in. So I want to talk about these 3 things in a bit more detail, both to explain what they are and why they're important, but also to focus on how you can apply them for your Spring-based applications. I will start with good old logging because, Ren and Stimpy said it better than anyone else. I think everyone needs a log. That has been true for a long time already for every type of application. This is not specific to microservices or specific to Spring in any way, of course. So the idea with logging is that you get individual events that typically contain a timestamp and a message to indicate, okay, something that's noteworthy is happening right now. Now, when you look at Spring Boot, when you just use it out of the box with its managed dependencies, will provide you with logback as a logging implementation. You can switch to others like Log4j version 2, for example. The first Log4j is actually deprecated for a while. You shouldn't be using that anymore. And then on top of that, Spring Boot actually adds some nice functionality. For example, if you have worked with Spring Boot at all, you will be familiar with the colored output that it produces on the console. For use with logback, there are actually some reusable fragments that you can import into your own configuration. So you can reuse parts of the Spring Boot defaults. I'll show you that in a moment. Typically, when you use logback, you configure it in a config file, which is called logback.xml. If you rename that file to logback-spring.xml, you actually get some additional functionality, like being able to reference properties that you have defined in your Spring environment through property sources. Last but certainly not least, Spring Boot also allows you to configure certain things about your logging through Spring itself, rather than in the logback XML configuration file. Now, nowadays, modern applications typically do not just log to a file anymore and say, okay, this is it. If you want to know what happened, you just SSH into the box and you start to use tools like grep and log to see what's happening, right? There's a number of reasons for that. In many cases, services or platforms that we are building no longer consist of a single application. They consist of many different services. So there's just too many to individually grab all of those logs, or there might be multiple instances of the same application running on multiple servers. But there's also other practical stuff, like for how long do you want to maintain that logging history? If that's a full month's worth of logging and you're doing a lot of logging, it's very often not feasible to just keep it on the local disk that your server is running on. You need to move it somewhere centrally and have a way to actually monitor the usage there and make sure that you have your SLAs in place, that the logging is actually kept for a full month. With containerization becoming a more popular approach for deploying applications onto Kubernetes or other Dockerized environments, you don't even know very often where your applications are running exactly, because there will be an orchestrator that will just make your application run wherever there is some room to spare, so to say. Also very important, if you actually have multiple services, you typically want to be able to look at multiple logs at the same time, right? Correlate things, see them over time, that sort of thing. And none of that can actually be done if you're simply just logging to a file. So that means that most applications nowadays will actually ship their logs off to some centralized log aggregation server. This could be using an alt stack. It could be on-premise. It could be in the cloud. It could be commercial servers. There's tons of options for this nowadays. And then you will use a service to actually look at your logs, to browse through them, to tail them, but also to do searching, to do alerting maybe based on things, to find patterns, all sorts of things that are typically supported out of the box by these platforms. And the way to do that is typically one of two things. Either your application will have a custom appender, and then that appender, and therefore your application itself, is actually responsible for shipping off the logs to some remote server endpoint, or your application simply logs to a file, which it could do itself with a custom appender. But in the case of Docker, that simply means typically just logging to standard out. And then the output from standard out is just captured by the Docker daemon and put on the file system. And then a separate process will be responsible for picking up those log files and then shipping them off to a server. It's worth thinking about these two options. When it comes to the required amount of configuration, the custom appender is very often an easier one, right? For example, we've used logs.io in the past, which is a hosted Elk stack, basically. They just come with a custom logback appender. You put it in your config file, you put an API key in there, and you're done, basically. But there are some potential downsides to this approach as well, especially because you need to take into consideration what might happen if your remote logging server is temporarily slow or unavailable, right? You don't want to block your application while it's producing log messages. So that means they need to be asynchronous and they need to be buffered, but you can also only buffer so many messages in memory before you're running into problems there. So in our experience, typically it's easier to just log to an external file, either directly or in the case of Docker, by simply logging to standard out, and then having some log shipper responsible for actually taking your log files and shipping them off to a remote server and then cleaning up the logs on a local file system that it has successfully shipped. And that's the approach that I'm currently also using in the platform that I'm working on. We're building a big integration system for the Dutch lotteries, and we are using an observability backend, which is called Datadog, which is a commercial service. And this is how we do our logging. Now, another aspect that's important to think about is how do you log? And by default, for example, with Spring Boot, you get logging that is shown on this slide, where you have a certain log pattern. Typically, that starts with a timestamp. Then there is a log level. There is some other information in here, but from this slide, we cannot even see what it is because there is some empty array there. But typically, this would be something like the tracing information in there. There is some other data like the thread name. There is the logger name, and then there is the log message. Now, this is fine for local consumption, right? As a developer, this is exactly what I want to see while I'm writing and running my applications. However, this is not ideal to simply ship off to some log server, because that forces the log server to be able to make sense out of these patterns. And many applications, and that could be either custom built applications that you built yourself, but also standard services like Nginx or Apache Web Service and those type of things. They all have their own log formats. So that all needs to be configured. But another problem is that this is actually quite lossy, right? We're losing information in this. If you look at this screen, we can see that the logger names, for example, do no longer have the full package name simply because it doesn't fit on the screen. So in this log pattern, they just reduce that to individual letters. This is perfectly fine for consumption on the screen, but it's of course less than perfect for shipping off the logs to a central endpoint. You don't want to lose that information. Another problem that I see a lot with people choosing this approach and then shipping this off is when you have multi-line messages. And multi-line messages in Java typically means stack traces. Right? If I have a stack trace, then instead of having one line per log method, per log message, all of a sudden I'm going to have a lot of lines that actually belong to a single message. And somehow you need to be able to make sense of that and know where the message ends and the new message begins, which is, again, quite tricky to get right. Now, there are solutions for this. So the Logstash Grok, for example, that I have on this slide is a solution for doing all of this parsing and analysis. And they ship out of the box with a lot of patterns for well-known services. But I would not recommend this for your own Spring Boot-based services. I would recommend to use structured logging instead. And the idea behind structured logging is that instead of having a pattern, we're just going to use some data formats, which is typically just JSON with key value pairs. And we will just put everything in a big JSON and we'll ship off the JSON as a single log message to the server. And many aggregators, many log servers support JSON as a format out of the box. You don't need to do anything special for that. And they will simply expect certain standard names like a timestamp field and like a message field and a log level field, those type of things. You may need to tune this a little bit depending on the solution that you use. But doing this, first of all, get rid of all of the problems that we saw on the previous slide with things like message loss and multi-line messages, because all of that is easy to encode in a JSON. And as an additional benefit, it becomes very easy to add certain additional fields that you would just always want to include with every log message. If you look at the example that I put on this slide, you can see that we have some information that's actually specific to this one log message. But then there's also at the bottom a service and a region. And these would always be the same for this particular application, right? It's always logging as the player experience, which is the name of an actual service in our platform. And this one is running on Amazon in a region EU West 1, which is in Ireland, in Dublin. And that's information that we want to be able to use to do filtering and searching of the log. So we want to include it. But that's typically not something that you want to do in your code whenever you send a particular log message. So putting all of this together, what would this actually look like for an actual Spring Boot log configuration? So here's a simplified example that I took from our own platform where I can show you some of the functionality that I was mentioning in terms of what Boot has to offer. The first thing that you see here is a property. That's a standard logback property. A logback can inspect environment variables and system properties. So in this case, what we do is we say we expect an environment variable, which is itself called environment. And we'll take that value. If it's not defined, then we'll have a default value, which is just local. So the :dash syntax, that's actually a logback syntax that says this is how you provide a default value. Then the next thing that you see is that we have a bunch of includes. So we can include log fragments, which is actually a super nice feature, I think, of logback. But the first two includes that we do here are provided by Spring Boot itself. So within Spring Boot jars, you will find these two files, the defaults.xml and the console appender.xml. And what they do is they define some defaults for things like log patterns and also some customized log levels, for example. And the console appender then actually defines an appender that you can use in your own configuration, which is called console, just console. We also have our custom fragment that we include here, which is called console JSON appender, and I'll show you that on the next slide. And then we use an extension of logback, which is using the Genino library that allows us to do simple conditions like if-then statements in our log configuration. So by that we can say, well, if we're just running locally, so there is no environment variable configured, or it's explicitly set to local, then we're just going to use the default Spring Boot logging. And we're going to log into the console using the pattern that we saw 2 slides back. But if we're running in any other environment, and in our case, all of our environments always have an environment variable specified that says, am I the development or the acceptance or the production environment? Then instead of using the default pattern-based logging, we're going to include this console JSON appender. And that one is actually defined here in this slide. What you see here is, first of all, a Spring Boot feature where we're defining a Spring property. So this is not just property, this is Spring property. You can only do this if your logback configuration file is actually called logback-spring.xml, because then Spring is early enough involved with setting up logback that it can actually do this sort of thing. And in this case, we're getting a variable called Spring application name. Now, we were chatting very briefly before we started the presentation, and some people were asking questions about Spring Cloud. If you are using Spring Cloud, then you are familiar with the convention that every Spring Cloud application defines a Bootstrap configuration file in which you define a Spring application name. And that's going to be a name that you can use for registering your service, for service discovery, for fetching centralized configuration. And we're going to grab that name here, and we're going to include it as a custom field with all of our logging, right? So this is how we can do things like making sure that there is a service in there for every log message. Similarly, I showed you that we also want to do that for the AWS region. Now, the AWS region is not available by default as an environment variable or anything like that. So for this, we're actually using a logback feature that I quickly wanted to showcase here, because I know that a lot of people are not familiar with this, which is called a property definer. So we're referencing a class here, a custom class that we wrote. And from that, we're going to get a variable called AWS region that we simply include here with the logging. And I'll show you on the next slide how to implement such a property definer. Now, before doing that, the most important thing actually that I wanted to showcase here is the encoder that we're using for this appender. So this encoder is called the Logstash Encoder, and this is part of the Logstash project. That's actually part of the Elk stack, but you can use it without doing anything else related to the Elk stack, Elasticsearch, Logstash, Kibana, because what it does is it takes a log event from logback and it encodes it as JSON. Right, so this is a very easy way to make sure that you're using structured logging. It has a bunch of defaults for things like field names. You can tune those defaults actually in the XML. I haven't shown it on this slide, but we actually do this because we ship off these logs to Datadog. And Datadog has some expectations on what the name will be of the field that includes your logger name, for example. So we actually configure that here as well. With that setup, you now have structured JSON logging. And in our case, it's just sent to the console because we're using a console appender, as you can see here. That means that it will be picked up by the Docker daemon that will put it on the local file system, and then we have an agent that will actually forward those logs. Final thing is this one. This is the custom property definer. So in logback, you can write a class that extends this property definer base. And then by implementing this get property value, you can programmatically determine the value of something that you want to use in your logging configuration file. Right, so this is a perfect way of making sure that something like an AWS region can be looked up at startup, basically, and then be put in your config file. This will only be called once, by the way. It will not be called repeatedly by logback. So this is a large portion of how we set up our logging in our Spring Boot-based applications. Question, of course, is, well, if you have this in place, then what will you actually log, right? When do you include code that prints out or it sends out log messages? And what I've seen is that a lot of people, I think, do not do enough logging. And that can mean one of two things. It can mean that they're only going to log things that show when there is a very clear error, right? And that's, I think, is simply not enough logging, in the sense that you should also be logging things that actually happen according to the happy path, but you should not log them at warning or error level. You should log them at info. But they should be there, because it's important to be able to see what your code is doing. Also, if it's just doing the right thing, right? Not just if there is a problem, because that is also very informative. The other thing that I see a lot where I think people are not doing enough logging is that the log messages do not contain enough information, right? It's not very useful if you see a log message that simply says, hey, something went wrong, or there was an error. You need always to put as much contextual information in your log messages as possible. So things that I mean by contextual information are always like, with what parameters was the current method that caused an error called, right? I want to log those parameters because they are probably important to determine the cause of the error itself, right? I was doing something, so what was I doing? But there can be much more. For example, most of us, I'm assuming, are building some type of web service, which could either be a web application with a UI, or it could just be an API implementation. But that means that you're typically executing code in the context of handling an incoming HTTP request. Knowing which request that was is actually super useful. So it's something that you could actually make available with all of your log messages. And that's actually relatively easy to do. If you're in a different setting, so maybe you're building a batch application, for example, then make sure that every log message includes the name of the batch job that you were running. Right? Because you might have shared code that is not specific to any one batch job. So if I see a log message, I want to know, okay, but what job was actually executing when I was producing this particular log message. So that sort of thing is important. And there's two ways to do this. You can simply include information in the log messages themselves. You can also consider to put things in a mapped diagnostic context. So what is a map diagnostic context, or MDC for short? It's basically a map with key value pairs that you can associate typically with the currently executing thread. So this is assuming a thread per request servlet-based application. But there are ways to get similar results with reactive applications. And this is a very nice way to ensure that you make information available to all of the code that's running in a certain thread, so that you can make sure that it gets included with your logging. So things to consider here are things like the currently executing URL that I mentioned. If you have authentication, maybe the current user that's logged in, so we can log the username. If you have a multi-tenant application, you probably want to know the tenant on behalf of which you are executing things. This is also very important information. And what we typically do is we have some type of servlet filter, for example, that can populate this. So here you see a simple example. We're extending Spring's one per request filter here. That's just an easy way to come up with a servlet filter, standard servlet filter. We get the URI of the currently executing request. And then what we do is we store that in this MDC under a key called URI. And simply by doing this, combined with the structured logging that I showed you on the previous slide, this will automatically include the URI with every log message, because by default, that Logstash encoder will just put the entire MDC contents in every log message. The reason that you see this try statement here, by the way, is that this is based on thread local. So whenever you put something in the MDC, you also have to make sure to get it out again. Otherwise, it might be seen by the next thread, and that information should not be there. And using this try with resources statement is a way that logback enables you to actually make sure that it's always taken out of the MDC again after the code within the try with resources statement has executed. There's nothing specific about that in terms of Spring. This is simply a logback feature. Logback supports this natively. You can also do this with Log4j. So this should be available with your popular logging framework of choice. And this is definitely worth looking into if you're not using this yet. Now, I saw a question already. I'm trying to also keep up with the chat, but of course I won't be able to see everything. But what about things like changing log levels on the fly? There are a number of ways to do that. Before I get into changing them on the fly, it is actually a really common concern to say, well, for certain environments, I want to have different logging configuration when it comes to do we do debug logging, do we do info logging, do we only do warning levels? Those tend to change from environment to environment. You could, of course, create custom logback XML files for every environment, but that's sort of tedious. Actually, a much easier way to do this is to simply use some Spring configuration. Because even if you have something like a logback spring.xml, you can still put configuration in your regular Spring configuration. Right? This could be properties file, a YAML file, it could be centralized configuration, system properties, all of the ways that you can define a property source within Spring. And there you can actually configure custom logging levels. And the way to do that is to simply have a property where the name starts with logging.level, and then you put in the name of the logger and you put in the actual log level. So, for example, in our system, we have application local properties under source control for when you are developing locally. We'll simply have a Spring profile active called local then, so the file will get loaded automatically. And this provides us with an opportunity to do more logging during local development than we would typically do in a production scenario, for example, simply by defining some custom loggers there. You can also combine this very well with Spring Cloud Centralized configuration. So if you can put your configuration for multiple services in a single place and then just push that configuration out to all of your services, and this means that you now have a single place where you can actually control custom log levels that your services will use at startup when they are running in a particular environment. So it's easy to have this environment-specific log levels. And that's something that we use quite a lot as well. When it comes to on-the-fly adjustment, there are multiple options. I think it is always important to have a way to actually tune the log levels of applications as they are running. Because again, like I said, with observability, the goal is to actually be able to observe your running applications without doing things like redeploying them or restarting them. If you're using Spring Boot's actuator functionality, there is a default loggers endpoint through which you can make HTTP requests to actually retrieve logging levels, but also to change log levels on the fly. That's a really nice way to do this. This is easy if you just have a single application or a small number. If you have like a fleet of microservices and you have multiple instances of applications running, that's not really a nice way to do this, right? You would need to be able to call all of the different applications running somewhere internally within some data center. So in that case, something to consider is to use a project like Spring Boot Admin. Spring Boot Admin is a community project. It's not from VMware. Or Pivotal, but it's from a German company, Code Centric, I think. Well, the name just eludes me. But Spring Boot Admin actually allows you to get an overview of all of your running Spring Boot services, either through explicit configuration or through service discovery. And it has a UI in which you can actually do this operation. So then you just get a nice user interface where you can just adjust log levels on the fly for all of your running instances of your applications. So that's definitely something to consider. There's a question here, by the way, with the thread local-based MDC and reactive Spring. Indeed, you should not use thread-based MVC when you are using a reactive framework, because it will fail. It will fail in the sense that you don't get errors, you will just see invalid information. That's something you want to avoid. With reactive Spring, actually the reactor library that's used by Spring, it has this notion of a context that is similar to what you can do with thread locals in a standard application. What I do not know is if someone has already written integration with something like an MDC-like framework for logback and Project Reactor. So I think you might actually be on your own if you want to do something like that, but it's not that hard to actually get that done because the building blocks are already there. There is a request context that you can use, and Spring itself actually uses that for things like Spring Security, for example. By default, Spring Security is also using thread locals to store the currently logged in user. It cannot do that with the reactive app, so it actually uses this functionality. Now, since we only have a limited amount of time, that's what I wanted to tell about logging. And then we get to this other pillar of the observability pillars, which is metrics. And what's interesting, I think, about metrics is that a lot of developers are not that familiar actually with them, certainly not as familiar as they are with logging. And the same is true for me. It's only been since Spring Boot 2.0 came out with a lot of support for this that I actually started to use metrics and learn about them and see what they are. And I was actually very surprised to see how powerful this stuff was, and that I somehow managed to go without this for 17 years in the business already. So I'm quite enthusiastic about the opportunities that this provides. Metrics are basically pre-aggregated information expressed through numbers, right? They can be timers or a counter, or they can be things like gauges that simply track a certain value over time, which may go up or down. That are collected and then reported periodically, like say every minute, so that some system can store them and you can do stuff with them. A good example when you're using Spring Boot is for every MVC controller endpoint that is being called, so you're handling an incoming HTTP request, there will be a metric for the minimum response time, for the maximum response time, and for the average response time. And from that, you can actually also infer the number of requests, so it's also automatically a counter. This is quite different from logging, because with logging, everything is an individual event. Every message is its own thing. That's not true for metrics. Metrics are pre-aggregated. So if I'm getting 100 requests in a minute, that will produce a single metric with a value of counter 100, for example. If I'm getting 1,000 requests a minute, I'm still getting a single value. It will just have a counter 1,000, but it's not going to grow linearly with the number of requests or with the volume that my application is handling. So that makes metrics actually quite different from logging. Now, by itself, if I would only be able to see, oh, this is the minimum response time for all of your MVC controllers in your application, that's not very useful. Right, because I'm going to have a lot of different controllers. So I need to be able, when I have metrics, to say, I only want to see these things. I need to be able to slice and dice them. And you can do that based on tags or dimensions. They are the same thing. And within the literature and within the frameworks, they are typically used interchangeably. So if you see tags and you have the term dimension in your head, you can just consider them to be the same thing. For something, a metric like that's related to HTTP requests, for example, tags could be the HTTP method that's being used. Was it a get, a put, or a post request, for example? What was the path of the request, right, the URI? What was the status code of the response? Was it a 200 OK, or was there a 500 internal server error or something else? So all of that information can be collected with these metrics, and then these metrics will typically be sent off to some time series database. And there you can do dashboarding, you can do graphing, you can do alerting, you can use these metrics for all sorts of things. As I mentioned, metrics were, I think, relatively unknown to a lot of people for a long time because there weren't really standard ways of either creating them or processing them. And both have changed significantly. On the producing side, Spring Boot, starting with version 2, actually came up with a whole new abstraction for this, which they put in a separate library called Micrometer. And Micrometer is like a facade for metrics. So that means it supports a lot of different time series databases. And it will automatically know how to actually export your metrics and put them into those systems. Next to that, what it will also do is it will automatically provide a ton of instrumentation for your Spring components. So if you have MVC controllers or Webflow controllers, it will automatically collect metrics every time that they're invoked. If you're using a REST template and you're making requests to downstream systems, automatically those REST templates will be instrumented, so it will gather statistics on all of those invocations. If you're using RabbitMQ or JMS Mesh Broker, it will do the same thing for that, right? All of that happens automatically. And that's the nice thing about using a comprehensive framework like Spring. It is involved in setting up all of those things and in integration with all of those systems. So it gives you a nice entry point to actually put this this instrumentation in. And when you're using Spring Boot with the metrics integration, that's part of the actuator, all of this happens automatically. What you do is you basically choose an implementation. So maybe you're using Prometheus with Grafana, so you need a Prometheus adapter, or you use a Datadog adapter, or you use an Elasticsearch adapter or a Humio adapter. There's tons of them actually. And then the system will just do the right thing automatically. So for most systems, that means it will start to push out metrics. For something like Prometheus, it's actually different. Prometheus is pool-based, so your application will expose an endpoint, and then Prometheus will know how to call that endpoint and actually extract metrics out of your system. Most newer systems that collect metrics are dimensional or tag-based, what I just explained. There are also some older systems out there that work slightly differently. They're hierarchical. I'm not going to talk about it, but they are supported as well. And different systems might use different naming conventions for what constitutes a valid name for a metric, for example. And again, Micrometer will just automatically make sure that whatever you expose will match those expectations of the backend. Now, if you're using metrics in addition to logging, because this is never an either or question, this is always something you use together, there are a lot of benefits that you get with metrics that are not present in logging. For one, like I explained, it scales much better, right? If I'm getting 10 times the load, my metrics will be 10 times as high, but I will not have 10 times more metrics. And that's a huge difference with logging, because the volume of logging typically scales linearly with the amount of work that your application has to do. That also means that once you actually store all of these metrics and you want to view them over a longer period of time, it tends to be way faster to process, because going over, let's say, a full month worth of metrics is a lot faster than having to go over a full month worth of logging, simply because there is so much more of it. That also makes them cheaper to store. And that in turn often means that you can actually store them for a longer time. So we, for example, in our system on production, we store all of our logs for a month, and then they get archived into S3. So you can restore them later on if you still need them, but it's a bit of a hassle. But a month is what we have by default. For metrics, though, we actually can keep them for 3 months because it's much cheaper to do that. Also, and that's for me, it was actually the most interesting thing to discover about metrics, something that I didn't expect when I started to use this, is that even without doing a lot of custom work, and without setting up your own custom metrics, just by using the standard instrumentation that's already there in your Spring Boot applications, you will gain tremendous insights into both what's happening in your application at an infrastructure level, right? How much memory is it using and how busy is it and that sort of thing. But you will also be able typically to extract a ton of business information out of that. Like how well are we actually doing in terms of revenue? How much products are we selling? What do we see as patterns over time in the behavior, how people are interacting with our application? All of that stuff is actually quite easy to get from metrics. I'm first going to quickly show you some ways to tune this, and then I'll do a short demo of this. So one thing, like with logging, that tends to be important is to make sure that you can actually slice and dice on all of the right dimensions or tags. So what you see here is an example of how we can actually add some custom tags to every metric that gets published by our application. In this case, it's the same values that we also want to have for logging, right? So we're extracting the service here, and we are extracting the AWS region. And by using this customizer, we can ensure that these values will be included with every metric that we have. So we can easily see that things were specific to one service or to one region, which is actually really interesting. It turns out, because of the way that we do load balancing, for example, we don't have similar loads in the two regions that are on AWS that we're running in. And we can easily see that based on this information that we have here. Slightly more complex example, but I just wanted to mention the use case here. We have a number of endpoints that are not called very often by actual clients, but we do have our own monitoring running continuously that simply checks if certain endpoints of the application are healthy and okay every now and then. And what we saw is that sometimes that monitoring traffic tends to drain out the real usage of the application. So when you look at certain metrics, basically you're just looking at your own monitoring. And we wanted to be able to say, well, I'm not interested in my own monitoring. I only want to see the real requests that people are making. So what we did is, for every monitoring request, we simply include a request header, which is called X monitoring in this example. And then I have this meter filter that says, well, we're going to get the currently executing request. We're going to see if that header was set. And if that header is set and it has the value true, then we're going to put that in a monitoring request true tag. And otherwise, we'll have a monitoring request false tag. And this then simply allows me to do filtering on metrics to see whether they originated from our own monitoring or if they came from real clients. Not that interesting for high volume endpoints, because the monitoring will just be a fraction anyways, but definitely a good use case for things that are not called that often. Now, to show you a little bit more about what this actually means, because this is rather abstract if you don't actually see it in action. Here we have a pre-production environment of a system I'm working on. I'm not going to show you real production data. But here I can start typing and I can see what metrics are available. Let me make this a bit bigger, because otherwise probably not legible. For example, I was talking about the MVC controllers. MVC controllers actually produce metrics called HTTP server requests.something. So I can see response times here, and I can also just do a count. So maybe I want to do a count, and if I do this, what I'm now seeing is how many requests are being made to my entire application across one day. And that's actually pretty quick to draw. It's also not very interesting. This is just for my entire platform, all of my services, all of the instances, everything. So typically, I want to be able to drill down here. So if I look here, I can see all of those tags that I mentioned. So I can filter on a bunch of things. I can filter on HTTP methods here. I can filter on the outcome of certain requests. I can filter by what service produced it. So for example, maybe I'm only interested in requests that were being made to a certain server. So now I can do that, and now my output here will just show the calls that were made to this game experience. Now from here, maybe I want to know more. So I'm say, well, let me just split this up by HTTP status. So what I'm going to see now is that these are all of the requests that produce a 200 OK. But I'm also going to see requests that produce a 304, which means clients is allowed to cache something. Those should be really quick. So if I don't draw the count, but the actual time it takes to execute these things, you will see that these things are super quick. And I can also see the other statuses. In this case, the platform is pretty healthy. So there's not a lot of errors, fortunately. I do see a little one here, so I can actually zoom in on that. And then I will just see the time range for this one. And this allows me then to say, okay, apparently around noon, in this case, there were some errors that produced 500. So maybe now I want to dive into the logging and see what happened in this time period, right? And if you have integrated tooling like this, this is really just a click of a button away. I can just say view related logging, and now I can actually see the logging that was for this particular time period. Right. With this, it's also very easy to start building dashboards. So, for example, we have a backend system that we call using a REST template. And from those REST template metrics, we can easily build dashboards like this one. Let's make this a bit longer, where we can say, okay, on average, it took this long to actually call this particular backend system. The maximum response times we do here. We see how often we actually call this system. And we do this for a number of different things. This is all stuff that basically becomes available out of the box. You don't have to do anything special for this if you have metrics. There's no custom metrics in this. All of this is just supplied out of the box by Spring Boot. Right, so that's what I wanted to share there. And then finally, and I'm going to wrap it up because this is a bit of a shorter topic, there is tracing when we talked about the pillars. So what's tracing? Tracing is the idea that whenever a request comes in to our platform, it might actually be handled by multiple services. And all of those services produce logging. But I typically want to be able to correlate that. I want to be able to see, okay, so what's the full route that a request took in being handled by my platform? So what we can do there is we can simply create a unique ID when a request comes in, and we can somehow make sure to propagate that ID to every downstream service that we call. And then that one will also know about that ID. That's called a trace, and that unique ID is called a trace ID. Every time you go to another service, it will start something that is called a new span, and together these spans make up a single trace. Now, it's also an option to take this information and actually export it to a custom system that will make all of these traces visible. There's a couple of options for that. One of the older systems that's still very actively used and developed is Zipkin for this. There is out-of-the-box support for that. Part of the Cloud Native Compute Foundation is Jaeger. But a lot of companies actually, both in the open source and in the commercial space, have custom solutions for this as well. Elastic has a custom solution for this nowadays. Datadog has as well. There's New Relic. There's all sorts of companies that do this. Very often this is based on sampling. It's too expensive to take every trace and always export it, unlike with metrics, for example. So you will just take some percentage, for example, and then make sure to only export that. Now, this is something that's supported in Spring by using a library that's part of Spring Cloud called Spring Cloud Sleuth. And what this one will do is it will actually integrate with a library called Brave from Open Zipkin project. to make sure that you get these trace IDs and that they're propagated automatically. And again, for that, it uses all sorts of instrumentation. So it will automatically make sure that whenever you're using a REST template, for example, that some header is actually populated with the currently executing trace ID, the span ID, and also a parameter that indicates if the trace should be exported or not. And that all happens for you automatically. You can also propagate additional information with this, except apart from the trace ID and the span ID. For example, we're running on AWS. AWS has load balancers that also have this notion of supporting trace IDs. However, their trace ID is a really weird one. You can actually see it here, and it's the part that comes behind the root attributes here. That's actually the trace. And the self here is more like the span. Now, we actually care about logging this stuff and propagating it across service calls, because when we make a call to a downstream service using a load balancer within Amazon, we actually want to make sure that we're using the same Amazon load balancer ID. For this, there is a very useful feature, which is called baggage in these frameworks. And baggage is simply standard headers that you want to propagate with every request. So by a simple configuration property, you can say, well, the X Amazon trace ID header, for example, should always be propagated with every call that I make to a downstream service. What we also do here is the X monitoring one. I showed you that one on the metric slide. The X monitoring indicates if something was originated from a monitoring request. You could just propagate that to downstream services as well, and then those services will also be aware of if they are being called in the context of a monitoring request. Even though they were not called directly, they were called indirectly as the result of calling some other service. And again, it doesn't require any custom coding to do this. It's just a matter of configuration. And then Spring Cloud Sleuth will automatically ensure that these headers get propagated with every call that you make. This is also integrated with the NDC that I talked about before. So those trace IDs will automatically end up in all of your logging, assuming that you are including the NDC context with your logging. So what we see here is part of a screenshot from Datadog where we see our logging. So you see the log message and you see the logger name and some other things, but you also see these attributes. And if we zoom in on that a little bit, then we can see that we actually include this AWS trace ID with all of our logging. So we can easily correlate this to load balancer logs. But you also see the trace IDs here from Sleuth itself. So with this, we can always immediately say filter and give me all of the logs from all of our services that were related to a certain request that came in. We also see the URI that I showed you before, right? So this gives me context. I know in the context of which URI we're actually producing certain log messages, as I showed you before, and we see some other information that we typically include. Right? So this actually puts it all together. We can start from something like metrics. We can spot an anomaly. We can zoom in on the logging. From the logging, we can easily filter on trace ID. We can see all of the related logging in place. And we have enough context in that logging to actually know what it was that we were doing. And this is very useful. But what's even more useful, and if you only remember one thing from this presentation, this is the tip that I'm going to give you. Even just if you're not using a microservices architecture, if you enable Sleuth, and you add code that I show you here on this slide, what that will simply do is for every trace ID that you create, it will also put that trace ID in the responses that you send back to every client. And this has been a huge time saver for us. We are building an integration platform, so we have a whole number of different companies that integrate with us as clients. And especially in development environments, these people will come all the time and say, hey, we're calling your service and there was a problem. And it could be a bug in our system, it could be a bug in a downstream system, but they want us to have a look. Now, in the past, when these sort of things would happen, these sort of requests would typically come in like, yeah, yesterday, around 5 o'clock, I think, I made a request. Could you please have a look in your logs? And then you look in your logs and there's like, yeah, there's 10,000 requests that were made around 5 o'clock. I have no idea which one was yours, so I'm sorry, go F yourself. With this, what we can do instead is we can say, well, we put the trace ID in every response. So we train clients to actually look at this. So whenever they want us to find something in the logs to find out why something went wrong, they know that they have to pass the trace ID to us. And with this, we can do an instant lookup of all of the relevant logging that we have in our application. We actually have shortcuts for this in our browsers with an alias for a URL with a placeholder in there. So I can copy paste a trace URL in my browser and immediately see the logging on any environment for a request that the client makes. And this is a huge time saver. It means you can instantly do triaging and you can find out what was happening when there was a problem and serve customers. And this is not just useful when you have a lot of different services. This is even useful if you have a traditional monolithic application because it still provides you with instant lookup of logging that was relevant in the context of a certain request. So this is something that I'm going to include in every application I will ever build from this point on. And I would advise you to do the same. So that was it.